Great. So hello everyone. I'm glad to participate in one of these events. So thanks for having me today, and I hope my talk will be useful for you. So I'm Alexander. I'm working as a Java developer at EPAM Systems, mainly working on the enterprise level project within fintech and e-commerce domain. I want to share a presentation. Can you see my presentation?
Yes, we can see.
Yeah, okay. So briefly, this slide about me, nothing special, so I skip it. Briefly about company, EPAM System is a global digital transformation service provider which specialized in IT strategy, technology-driven transformation, digital platform, engineering, digital product design, and more. We serve our customers all over the world in more than 50 countries across 6 continents. EPAM was named by Newsweek as a most loved workplace in 2021, ranked the top IT service company on Fortune's 100 fastest growing companies list the last 3 years, and listed among the top 15 companies in information technology service on the Fortune 1000. So there are just 3 points that I have noted, but there are many more. More information you can find on our website, epam.com. And yes, we are hiring. Again, you can visit our website or connect with me via LinkedIn to get additional information. So, all right, today I'm going to tell you about migration from old Java and Spring Boot versions to new ones. And basically, I will talk about migration from Java 8 to 11 and from Spring Boot 1.5 to 2.3. I will share with you my practical experience, actually through a story, how we've done it with my team for a really huge banking system. So let's start. Here is the agenda. What we had at the beginning and our goals. The first approach to the migration task. I will talk about useful migration documentation and tools. Also, we talk about where to begin with Java or Spring Boot. From at first sight, it can be like a simple question, but there are some underwater rocks. Then I will show you a bunch of examples of errors, exception, and their solutions. And at last, finally, it will be one interesting thing which we didn't expect at the end of our activities. But firstly, I would say a few words about why exactly Java 11 instead of Java 17 or other version, and why Spring Boot 2.3 and not higher. The last new release reports dated from May 2022 shows that Java 11 has become a new standard Java in production. However, not far ahead of Java 8 yet. Java 11 takes about 48% and Java 8 takes 46%. So they are equally used in production. Newer versions only make up a few percent, such as Java 17. And older version, the same. That's why Java 11. You can follow the link, by the way, or scan a QR code to open and see a full report. There are many interesting things, statistics about JVM ecosystem, language-related, cloud computing, and more. As regards Spring, the most important here is that I'm going to focus on migration between major versions, and specific version is not so important. I believe that the approach I come up with will be useful for any versions, give or take. So what we had at the beginning. A huge backend system consisted of 400 microservices, libraries, components, internal components. In fact, we had an architecture where is in the baseline microservices and libraries that provided functionality as a platform. And on top of that was microservices with customer business logic. And also we have well-tuned CI/CD workflow with Bitbucket, TeamCity, SonarQube, Kubernetes, and other stuffs. So our initial task was to successfully implement proof of concept, namely take a few microservices, make a migration, then to test them, make a release versions, and deploy into the production. At the same time, prepare a knowledge base for another teams which will be doing the same job with their components after us. And at last, providing expert support if they will struggle with something or have any questions. So I'll first do the task. What we expected: upgrade Java, upgrade Spring and other dependencies, fix the compilation errors, maybe some runtime errors to adjust configs, deploy to Kubernetes, and basically that's all. That is what we expected. But in fact, we've got a lot of broken tests, inability to raise and run the microservice due to application failed to start error, and a bunch of exception errors in runtime if start of application was fine, even if start of application was fine. By the way, on the slide, you can see a real cloud of those errors that we met: class not found exception, not such method error, class loading errors, and more. So we were taking first, second, third service and constantly faced these errors. And at some point, we got stuck and couldn't move forward. Often it was not clear where those errors came from. For some time, we suffered until we decided to analyze the architecture of the entire system. Have a look at this, please. This is a strange diagram. It shows connections through dependencies within POM.xml between microservices, libraries, and repositories of other internal components. In other words, the repositories, the microservices are tightly coupled. This is a fairly frequent problem in a big system, especially when it comes to enterprise level project where the system has been coded for many years. When we dug into the microservice repository, we saw that in addition to the microservice module itself, the repository also includes microservice specific libraries that are consumed by other microservices as Maven dependency have direct imports in the source code. It's like a microservice architecture hides a huge monolith behind it. This is such an architectural compromise when it's more convenient for the teams to maintain all related components of the microservice within the same repository. Simplified support, simplified maintaining, versioning, and etc. But what is the problem here in scope of migration? The bottom line is that in order to migrate the microservice to the new Java and Spring Boot, ideally all its dependency must also be on the new Java and Spring Boot version. If some dependency are on the old Java and Spring Boot, then most likely the service won't compile, or you will have runtime exceptions, errors due to the incompatibility, because here we have a tight coupling. So to put a microservice in production, we needed migrate the microservice and all its dependency to new Java and Spring Boot, successfully deploy and test on dev and stage environment, make a release versions of all dependencies, and release the microservice itself. But in condition of tight coupling, where one repository is dependent on another repository, which in turn depend on the next one, and so on, then when you have about 400 microservices that are supported by dozens of teams, migration becomes not an achievable task, really. And you cannot go the other way by injecting dependency on Java 11 into service on Java 8 version, because in this case, you will have build failure with error message like class file has wrong version bytecode. Yeah, on the slide you can see a version mapping table between Java and bytecode. So we were having all this problem rolled into one. Every time there was a component in dependencies which produced errors. Also, we try to follow other way and leave some dependency on Java 8 and gradually move only a part of them. But we faced this class file has wrong version error because of anyway Java 8 component consume Java 11 components through the deep transitive dependencies. So what the solution? In this case, the best solution is to allocate libraries and minor components on which microservices are dependent in separate repositories. It's necessary to granulate the microservices repositories as much as possible, but without race of complexity. All in all, need to achieve loose coupling. Yes, of course, here we still had direct imports in the source code, and we had not got rid of tight coupling completely, but as a result, we got small groups of components approximately consisting of 3 to 5 repositories, and we got separate components that do not depend on anyone at all. And it became quite possible to migrate individual components in this smaller group at the time, unlike the entire chain of 400 microservices. So based on that experience, we can summarize and identify the following questions that need to be answered before starting the migration. What components does the entire system consist of? Microservices, libraries, any specific components, maybe detached jar files, and so on. How many components do you have? If up to 10, then there are not so many problems, I guess. If there are more and you have some architectural trade-offs, some pitfalls, then there will certainly be problems. How components are interconnected, how they communicate with each other. Again, is it just a pure REST, a pure messaging, or are there direct dependencies and class imports that that cause tight coupling? If there is tight coupling, are they limited to small groups, or is it a problem like we had when a lot of microservices in the system was directly connected through libraries dependencies? If you have something like that, firstly, you have to figure out how can this problem be resolved. You also need to analyze if you have gut components. It's kind of components that many other depend on. You may have noticed on the slide with the diagram here, there were gut component on which many components depends on the top of the slide. Yeah, I put, yeah, you can see 2 big square and 2 smaller additional squares. That's because I have no free place for arrows to connect all these components. So yeah, if you have something like that, so such components also usually require special attention. And finally, I said a lot about internal components analysis, but not only there. Own components are interesting here, but also, for example, whether Spring Cloud dependency are used or some third-party components that are not supported on the new version of Java and Spring Boot. So before you start, extremely important to make full analysis of architecture of entire system. So there are 6 questions which I mentioned on which you have to find answers. Now let's talk about useful documentation and tools. And first, just briefly, I want to show you compatible matrix of Java and Spring Boot. You can see that Java 11 and Spring Boot are the best solution right now, from my opinion. Interesting thing that if you want to use the latest Spring Boot version, you have to move to the Java 17. And 2 tips for you. Don't make a big jump between versions and do not use unpopular version. Check the Maven repository for the most commonly used version. I mean, you can go to the Maven repository and search for one of the Spring Boot components. Let's take the most common one, for example, Spring Boot Starter Web. On the page, you will see all versions of this module, and there will be a column named as usages. So look here and choose the most popular one. If you ask me why, I will answer that if you choose the most popular version, then you have more chances to find a solution when something complex happened. More likely you will find answer on Stack Overflow or on GitHub. But if you choose some strange version, then there may be problems with resolving issues. That's why my advice to use popular version. Next, directly one universal guide or tool doesn't exist because every system is unique, and the migration process can also vary greatly from service to service. But anyway, here's what you can use: Java migration documentation and Spring Boot migration guide. Links on the slide. There are links about migration to Java 11 and Spring Boot 2. And also I added links regarding Java 17 and Spring Boot 3. Yeah, really great article with all useful information. So then you'll have to analyze dependency tree. So you need a software plugin or something else that allows you to do that, which in turn will help you to answer questions. Do you have incompatibility versions directly in POM.xml? Do you have incompatible transitive versions which are pulled from the underlying components? And it may be that some dependencies are missing at all. For example, they were not necessary in the previous version, but now they need. And a crucial point, really important for compatibility, is that the version must be exactly matched, because incompatibility can be obtained both with an outdated version and when setting a latest one. So the old version and very new can be equally incompatible with what you are switching to. Our team used Spring Tool Suite 4 as the analysis tool, convenient interface, and most importantly, there is the ability to search and filter in the interface. I can simply write the desired dependency in the filter line and see information about it. Where it was used, what version, does one version shadow in another or not, and so on. About shadowing, dependency shadowing. Shadowing happens when there are different versions of the same library in your dependencies. In this point, you have classes with the same full qualifier name in the class path. If the classes are identical, this isn't a problem. But if they differ, then any code using those classes will likely have unaccepted behavior, or even a runtime error may occur. Which class exactly will be chosen by class loader depends on ordering on the class path, and the same true for Maven dependency. Build tools such as Maven run a step called dependency resolution, where they identify dependency with the same group ID and artifact ID, but different versions, and resolve them to a single version. This guarantee that you will have only a single dependency artifact in your class path. And that's all. But problem is that wrong version can be picked up. And this is a common problem when you update some library in your POM.xml, but somehow still old version is using, and you may have problem of incompatibility. So it matters which version stands higher in the dependency tree. If old version, then it will shadow, or I'd say cover the new one. In this case, most likely you will have problems. How to solve it, you can see on this slide. Check the dependency tree and make sure that the same libraries have the same versions throughout the dependency tree. See the desired Sorry, can you hear me? Something happened.
Yes, we can hear you. Yes.
Just okay. I will proceed. How to deal with dependency shadowing? Check dependency tree and make sure that the same libraries have the same versions throughout the dependency tree. Set the desired version forcibly by duplicating and up the tree. Good article with additional info on this topic by the link. And you can see on the slide on the right side how it works. If you see logback JSON classic have independency logback classic version of 113 actually. There is a sign managed from 113. But logback classic also included in lib common pagination with newer version 1.2.11, which stands higher. So Maven choosing this one. But if the older version stands would stand higher, then it will be choosing by Maven. So about tools, about websites, key websites, jardownload.com or findjar.com, very useful as a tool in migration process. Maybe there are other websites with similar functionality, but I don't know exactly. Let's say you caught a class not found exception or any other error where some class that you do not know is specified. This website helps to define the Maven artifact by class name in which this class is located. And already knowing what exactly caused the error, you can dig further and figure out the reasons. As you know, compilation error are the simplest things that happens because you can see it right now. But runtime errors, it's not always even clear what caused them. For example, we see a class not found exception in the stack trace when the context try to initialize. We look at what kind of class it is and understand that in the current microservice, there is not even a hint of using one of another. One another component that would need this class. There is an error, but there is no obvious reason. For example, imagine situation if you had a service without test at all and without any test related dependency, just bare functionality. And at the start of the context, the service would swear at the lack of the class from Makita, for example. It's strange because we don't use tests. There are no dependency on test starters in our Maven POM XML either. There is no Makita, but there is an error. So what reason of the problem? And the only reason is that somewhere you have transitive dependency which impact on your context if this dependency compatible with new Java Spring. So algorithm of searching is you take name of class from stack trace, which causes an error, go to the jardownloaded.com website to find name of artifact which contain this class. Then you should deeply analyze the dependency tree of your application. For this purpose, you can use search and filter in Spring toolsuite for. After these steps, you will find cause of the problem and then we'll able to read off it. For example, you may find that your POM XML file or POM XML of underlying dependency contains artifact which version is not compatible with new Java or Spring Boot version. So you can look into table of compatible versions and fix the incorrect version. of the dependency in your case. Next, let's talk about debugging. Debugging skills are especially important in difficult cases when we weren't able to find a solution to a problem at all. We are simply debugging. Very often parallel, where we're running tests in debug mode simultaneously on the old Java 8 and Spring Boot and on the new one in search of difference. But there is one important thing, and the thing in the right corner, actually on the slide. You have to have tests, unit test, integration test, API controller test. The test should shout if there are any problem with migration. I know many examples when writing tests is ignored, but this is very dangerous in the scope of migration, because if something is missed during the migration, the service may work in general, but the functionality may break partially. For example, one endpoint does not work due to the fact that no such method error occurs. This is a runtime error, not compile time exception, and it occurs only if you have some incompatibility between versions of some dependencies, because of method can be exist at compile time, but it's not available at runtime. And the next one, table of compatible version. From this link, you can find a table of compatible version of various dependencies with the desired version of Spring Boot. I already mentioned this table a few minutes ago. You need to follow the link, select the desired version of Spring Boot, then go to the documentation and version of dependencies. As I mentioned before, it's extremely important to keep dependencies exactly match. I know by myself that the temptation is always there when you want to put a new dependency, and it tends to be a very new one, but do not do that. Set first recommended versions, and then after successful migration, after testing, you can try to raise version step by step, one after another. So check the table of compatible versions. BOM file, using of BOM file. When you have a zoo of microservices, I mean, when you have it a lot and they are different, but at the same time they have some shared dependencies, you want universal predictable approach in terms of dependency management and maintenance. In this case, a good approach would be using of BOM files. BOM stands for bill of materials. A BOM is a special kind of POM that is used to control the version of project dependencies and provide a central place to define and update those versions. BOM provides the flexibility to add a dependency to microservice without worrying about the version on which we should depend. But it's not enough just to have it. You need to use it effectively. And efficient approach is to maintain this file as an individual detached repository, which would have an open release lifecycle as a typical library repository. I mean that you need to have Git repository with only this single file. You want doing commits into this repository and frequently release version of this file, which should be as an artifact, which you, and not only you actually, but other teams, developers can include it into the microservices POM XML. This is very convenient when you can add this file in your POM XML, which contains reference versions of some dependencies which are broadly using on the project, and you needn't to set version explicitly in each microservice. Just add this file and everything will work by itself. It turns out centralized version control, synchronize dependencies between components. But there is one thing, as usual. This repository should be under strict control. It should have responsible developers who will strictly check every pull request that come in and make new release versions. At the beginning, we had a big problem when common BOM file was not controlled by anyone. Any developer could commit something of his own, change dependency versions as he wanted, and make a release. As a result, this led to the fact that the BOM file began to become literate and additional compatibility errors began to appear. So there was always someone who committed something wrong. And the only way to avoid this is to keep the file clean and under control. Another simple but important question is where to start, with Java migration or with Spring Boot. One thing is for sure, don't try to do it all at once in one gulp. Because if the migration is not simple, then at some point you can simply lose that thread. It will not be very clear what action exactly don't allow you to successfully move on. If you start with updating Java, if you start with upgrading Java, the pros are that it's easier than Spring Boot migration. If you migrate Java first, test it, and then move on to the Spring Boot migration, when you face non-obvious errors, it will be clear that at least it's not Java. It's not about Java. But there are cons. This is possible dependency over abundance in POM XML. For example, if you are using Makito 1 on Java 8, then moving on Java 11, you will need to change Makito 1 to Makito 2 by adding it to the POM XML. At the same time, this dependency are already in Spring Boot 2. So starting with Java, you need to add it to POM XML, but starting with Spring Boot, you needn't, because it is already in the starter and pull it up transitively. If you start with Spring Boot, then the entire threshold is higher. Generally, more work is required than when migrating Java itself. More errors, more difficult, unobvious errors, and so on may occur. But the project itself will be somewhat cleaner. And by the way, I would like to pay attention here to such a moment as reading the stack trace. Usually migration, in many cases, it is an iterative process. When over and over again, you try to up the context and run into a runtime error, then look for its solution, fix it, run the microservice again, up the context and face with the next error, look for a solution, fix it, and so on. So it's very important to count the lines in the stack trace, whether error was really passed and the stack trace moved further, or when solving the current error, we accidentally create a new one, and now we fall earlier than it was. It's especially important to keep track of this. We got into a situation when we thought that we solved the current problem, and now the next one, but in fact we didn't solve the current, but simply created a new that drops the context even earlier than it was before. Once we really wasted a lot of time before we saw that, so keep it in mind. Now let's see the most common warning exceptions and errors. And first of all, I want to say about illegal reflection access warning. Some tools and libraries, a lot of actually libraries use reflection to access part of the GTK that are meant for internal use only. In the Java 11, it is permitted by default, but a warning is issued. But since the Java 16, the illegal reflection access was disabled and strong encapsulation came into play. So it's mean you cannot use such libraries without additional adjustments on your site. Since Java 16, you have to use JVM options, at export and at opens. Also, you can use GDEPs or GDEP scan. First will help you to find which GTK internal APIs your project is using. Second will show uses of deprecated API elements, so you can analyze and read off them if you're able to. Yeah, of course. The next one is about removed modules. Java 11 removed several modules which was deprecated since Java 9. If these modules are used in the project, then you need to add them explicitly as the dependencies, or you can read of them by finding a replacement. For example, module with sun and commandant sun can be replaced by the bouncy castle API. But these modules are not limited. There are other that have been removed. You can find the full list at the link about Java 11 migration, which was here. Yeah, full list of removed modules. Next one about compilation errors. For example, Guava Cache Manager changed to Caffeine Cache Manager. It means that you have to make changes which are shown on the slide, and also need to add dependencies. Another example where you need to fix compilation errors. If you are using Apache Common Slang, you should change it on Common Slang 3. This one is interesting, and regarding Spring Boot. Before Spring Boot 2.1, overriding beans with the same name worked by default. The old bin was overwritten with a new one to avoid conflicts. Because you cannot have two bins with the same name in the same Spring context usually. As of Spring 5.1, an exception is thrown by default in such situation to allow developers to control this behavior. If you want to leave a previous behavior, you should add appropriate property, which shown on the slide on the right side. But it's error prone, and better solution is to find out how to resolve the bin name collision. Because when you allow Spring to override bins, and if you have two bins with the same names, but slight different implementation, you don't know which bin exactly will be chosen. It's unpredictable, actually. Overriding depends on the order in which the configuration classes were loaded by class loader. And this process can be varied depending on different factors. This is regarding compilation errors. One more time. If you are using Spring Data, then you will face with the fact that the API calls has changed. And you can see how on this slide. Find one was changed on find by ID, delete on delete by ID, and so on. In situation when you have a lot of calls of an old API, it required much effort to refactor all this. So you can go another way, create intermediate interface and make calls through it. It will be like a U adapter. You can see on the slide how it can be implemented. Yeah, and also a new API in most cases returns optional instead of null. So intermediate interface can cope with it too. Simple, but from my point of view, really annoying changes in Spring Boot 2 is to switch property naming style from camel cases to the keep-up cases. So you have to update all configuration properties annotation to meet Spring Boot to Spring Boot second version requirements. And you can see on the slide on the right side how it was on the old version, how it is on the Spring Boot 2. The next one, Again, the same story, which has an impact on the many aspects. PowerMock use its own class loader to load classes and cannot access the internal module, internal APIs. As I mentioned, it related to strongly encapsulation by default. You can solve PowerMock problems if add internal packages in the ignoring list through in this annotation. And the last one about security. For a long time, we could not cope with security disabling in the test. Finally, we found the solution, which on this slide. So yeah. Of course, I've described only a few examples of problems which you can meet during the migration process, because we have I can't cover all of them, and I guess no one know all of them. As I remember, in general, up to 100 points were described now knowledge base when we were working on it, and they are specific to our project. I can exactly say you will meet some of them which I've described, but also surely you will have your own. And yeah, and one more thing which we didn't expect and faced it at the end of our migration process, literally in the last 1 or 2 weeks before our committed deadline. When we are doing microservice migrations, we've been taking the last microservice release, which was on the Java 8, or just made a new branch from develop, and we're doing our job. So we often were working with the very last version of our internal microservices and libraries. But in the end, we've realized that a lot of microservices depends on the different versions of the internal components. Many of them were consuming old versions, but not newest. And we couldn't just put, for example, new version of some internal library in the microservice dependency, because in this situation, we have incompatibility, in this case, in the business logic. You can see API compatibility between servers of different version, business logic and incompatibility at the database level by tables and column. So all we could do was also migrate another versions of our components which still consumed. So in the very end, we had several microservices versions on the new Java 11 and Spring Boot. So you should to think about this point too before migration, how you will deal with incompatibility between different releases of your internal components. Which of them migrate? Maybe you should make a code freeze, or firstly update business logic of flagging microservices, pull them up, and only then migrate. Yeah, so I guess that's it. That's all for me. The last thing I want to note is do not delay with starting of the migration process. Do it frequently, keep upgrading Spring Boot often, Java as well, because if you do it on regular basis, you have less problems. And do you remember I said that don't do big jumps between versions? So that's about it. So thank you.